A limit is a value that a function approaches as the input approaches some value. This is the notation for a limit. Now let's just have a be some random number. What this is asking us is, as x approaches a, what does f of x approach? What does the y value approach? Now there are two more pieces of notation that you should know. If there's a minus sign next to the a, that means it's approaching from the left side. So what this is asking is, as x approaches a from the left side, what does f of x approach? The other notation is approaching from the right side. If there's a plus sign next to the constant a, it means that we're approaching something from the right side. This is asking, as x approaches a from the right side, what does f of x approach? Now for a limit to exist, the left-sided limit and the right-sided limit, they have to match. If they don't match, then the limit doesn't exist. And if they do match, then they need to equal the limit itself. So here's a basic rule of thumb to follow. The limit as x approaches some number from the left side has to equal to the limit as x approaches some number from the right side, which equals the limit itself. If the left-sided limit or the right-sided limit either don't exist or they don't match each other, then the limit itself will not exist. This is some random function. This is a discontinuity. If you remember from pre-calculus, this is called a hole, but in calculus we call this a removable discontinuity. The function itself doesn't exist at that point, but a limit might exist. So let's take a look at this example and let's try to evaluate the limit as x approaches 4 of the function f of x. What this is asking us is, as x approaches 4, what does f of x approach? What does the y value approach? Remember, first we need to find the left-sided and right-sided limits. So let's find the left-sided limit. When we're approaching x equals 4 from the left side, we're approaching here, which is y equals 1. This point is at 4, 1. So as we approach 4 from the left side, we're approaching the y value of 1. So our left-sided limit is 1. Now let's approach 4 from the right side. As we approach from the right side, when we're approaching x equals 4 from the right side, we're also approaching this point here, where y is 1. So as we approach f of x from the right side, we're also approaching 1. These two, they match. So that means we can say that the limit as x approaches 4 of f of x is equal to 1. So that's our solution. Now this one's a little bit trickier. Let's evaluate the limit as x approaches 3 of f of x, where f of x is the function right here. First, we need to find the left-sided limit. Now let's approach x equals 3 from the left side. As we get closer and closer to x equals 3, we approach this point right here. This is at y equals 5. So therefore the left-sided limit is going to be 5. And now let's evaluate the right-sided limit. As we approach x equals 3 from the right side, we're going to approach this point right here, which is at y equals 1. So this is going to be 1. Notice how the left-sided limit and the right-sided limit, they don't match. So therefore, the limit itself does not exist. And when a limit doesn't exist, we like to write D and E, which just stands for does not exist. Now if we take a look at this function, we'll know that this point does not exist, but this point does exist because the hole is filled in. With limits, all we really care about is the point that it approaches. We don't really care if it exists or doesn't exist. So get rid of this part of your intuition and focus more on if a limit approaches some value. Thanks for watching. This was a basic introduction to how limits work. In the next video, I'm going to go over how to evaluate more limits for more graphs, and then we're going to do it with tables, and then finally algebraic manipulation. So you can find those videos in my calculus playlist, either at my website dogedu.org, or you can find it here right on YouTube in the Unit 1 Limits playlist. Thank you for watching.